Hi, my name is Yasmin Nurin binti Muhammad Yusri and my friend Iffah Izzati binti Muhammad Jasmi, also Ainina binti Syahrul Nizam. Today I will be presenting the relationship between coffee consumption and self-read productivity. Next, introduction. Coffee is a habit for student UiTMs, often linked to increased alertness and improved academic performance. Students frequently rely on coffee to stay focused and manage heavy workloads. This project aims to investigate the relationship between the number of cups of coffee consumed daily and self-rated productivity level among UiTM students in Malaysia. By applying statistical methods such as correlation and regression analysis, we seek to determine whether coffee consumption has a significant association with how productive students feel in their academic activities. Next, the objective of our studies are determine the average daily coffee consumption UiTM students, assess the general level of self-read productivity among the UiTM student sample. Next, to understand the scattered plot and the correlation between the number of cups of coffee consumed per day and self-read productivity. And the last, to find the predictive relationship using regression analysis. Next, this is the data representation. We have table 1 response between the number of coffee consumed per day and student self-productivity, and also table 2 analysis respondent between the number of cup of coffee consumed. For this project, we use a secondary dataset simulate for 13 student UiTM. Each student report 2 values. First, the number of coffee cups they drink per day and their productivity score on a scale from 1 until 10. All values are quantitative and we analyze the data using Microsoft Excel.
So next is methodology. In our study, we apply a quantitative research approach by collecting secondary data through a structured survey via Google Forms. The survey targeted students from UiTM and we received responses from 30 participants. The key variables we analyzed were coffee consumption X is the number of cups of coffee a student drinks each day. This was recorded as a whole number ranging from 0 to some maximum value based on participant responses. Next is self-rated productivity. Y is student self-assessment of their productivity level on a scale from 1 to 10, where 1 indicates very low productivity and 10 indicates very high productivity. For data analysis, we organized the responses into a table that included the total, sum and square values for both variables. This allows us to perform statistical calculations such as means, variance and correlation. We use several statistical techniques to analyze the data, which is scatter plot, to visualize the relationship between coffee consumption and productivity. Next, correlation coefficient is to measure the strength and direction of the linear relationship between the two variables. And regression analysis is to develop a predictive models that estimates productivity based on coffee intake. This methodology helps us understand whether there is an association between coffee drinking habits and how students perceive their own productivity, and if so, to what extent. Move to this part, which is finding scatter plot and regression lines. The analysis provided us with a regression equation, which is y equal to 6.09 plus 0.34x, where y is the productivity score and x is the number of coffee cups. The correlation coefficient R was approximately 0.2272, indicating a weak positive relationship. This suggests that as coffee consumption increases, self-rated productivity tends to increase slightly.
Now, let's move on to the statistical result of our study. We wanted to find out if there is a relationship between the number of cups of coffee consumed daily and a student's self-rated productivity levels at UiTM. First, we found a weak but positive correlation with a correlations coefficient of R equal to 0.2272. Since the value is less than 0.5, it indicates that while there is a positive relationship, it's not strong one. So students who drink more coffee tend to rate themselves slightly higher in productivity, but the link is minimal. To understand this better, we use a regression equation, which is productivity equals to 6109 plus 0.34 times cup of coffee. For example, if students drink 6 cups of coffee per day, their pretend productivity score would be y equal to 6.09 plus 0.34 times 6, which is equal to 8.13. Next, let's discuss the slope of the regression line. The slope is 0.34, which means that for every additional cup of coffee consumed, productivity is expected to increase by 0.34 units on the separated scale. We also calculated the coefficient of determination, which is r to the power of 2 equal to 0.0516. This tells us that only 5.60% of the variation in productivity can be explained by how much coffee a student drinks. The remaining 94.84% is likely explained by other factors like sleep, academic workload, time management, and overall mental health. In conclusion, while there is a slight positive link between coffee consumption and productivity, the effect is very minimal. The findings suggest that coffee may have some influence, but it is not strong or significant predictor of productivity on its own. Now it's come to the end. Let's conclude our finding and discuss what this all means. Our data partially support the hypothesis. Yes, coffee consumption and productivity have a weak positive correlation, which is R equal to 0.2272, but only 5.16% of productivity changes are linking to coffee. So coffee might have a small effect, but it's not a strong predictor. Key reflection and limitation of this study include self-reported data. Students might have rated their productivity inaccurately. Second is potential confounders. We didn't control for factors like sleep quality, stress, or mental health. And lastly, a small sample size. With only 30 respondents, our result may not reflect the entire student population. From this, we learned that students at UATM do drink coffee and associate it with productivity. But since productivity is separated, the result might not be entirely accurate. Correlation and regression are helpful, but when correlation coefficient R and coefficient of determination R squared are low, they show weaker predictive power. For future improvement, we suggest first is increase the sample size to collect data from more students for better accuracy. Second is include more variables like study habits, time management, nutrition, and exercise. 3 is conduct a longitudinal study to track a coffee intake and productivity over time instead of just using a time survey. In a conclusion, while coffee might give a slight boost, it's clearly not the major solution for productivity. That's all explanation from us on our survey study. Thank you for listening.